Welcome to the last talk. And yeah, 45 minutes. This will be interesting to figure out how that works. I'll give it a try anyway, because I just recognized I'm the last person between you and the beer, which brings me in a quite dangerous situation, to be honest. Yeah, I hope so. Anyway, we had a lot of very interesting talks this day about technology, a lot of in-depth insights and so on. That's important, that's cool, that's fun. I mean, that's what we love, all of us love. This is a non-code, no-tools talk. I'm not really sorry about that, because I think we need both of it. We need this detailed knowledge, how to use all the tools, how to code the stuff. On the other hand, it's also quite important to have a little bit of overview, how that fits into the bigger picture, what is really used by the companies in the industry and so on, where's the trend going, and how can we fit all the cool stuff that we know into the demands of what's going on out there. Because that's what we are, in the end, writing software for. Not, okay, I love to write software just to have fun, but in the end, there's somebody who pays for that, and therefore, we better should make sure that it somehow also fits the needs out there. And that's more this kind of talk, giving you the big pictures, connecting the dots, figuring out how it all fits in. My name is Uwe Friedrichsen. I work for a corporate company called codecentric. I'm not going to bug you with a lot about codecentric. Let's make that short. We're cool. Okay, that's short enough, I hope. And I'm also not going to bug you a lot with my history. Also not that interesting. I mean, what we are going to talk about is this thing, DevOps. And if you go around and talk about DevOps, you see a lot of definitions out there, which are unfortunately all wrong. So what we most of the time see is a perfect confusion of ideas. And for the next 40 minutes, let's agree on one definition, therefore. And that's the one from the Phoenix project, which I usually call the DevOps Bible. If you don't know the book, figure out what it is. It's interesting, and if you really want to understand what DevOps is about, that's the book to read. There's also a DevOps handbook from the same authors, which came out with more technical introduction. This is a novel which gives you, in a fictional way, describes what it's good, what it's about, and how to learn about the core ideas. And what they say is, in a nutshell, DevOps is three ways, three concepts. These are the three concepts. Very briefly, let's step through them. The first concept is the concept of flow, system thinking. What we're going to do, we have an IT value chain. It starts with an idea and it ends when the customer sees the result of the idea and gives you feedback. And we try to holistically optimize that. And what we're trying to optimize it for is for cycle times. How fast can we deliver an idea out to the customers and get feedback from the customer? We'll see soon why that's important. The second way, or the second principle, is basically feedback loops, so amplifying feedback loops. Not only this ops to dev loop, but all kinds of feedback loops that are possible in there. Why do we need that? Because if something goes wrong downstream, it usually is caused by something which was made by mistake made upstream, somewhere upstream. And in order to avoid these problems, which makes you slow, so makes cycle times slower, you need to make sure that you bring the feedback upstream to make sure that they know what went wrong from what they did and how to avoid that later on. So building the knowledge upstream. And the third thing is entropy never sleeps, so we have to continuously try to improve all the time in a controlled way. So not just improving when there's time, because there's never time, or in some chaotic way, because that's usually also not very good, but in a controlled way. I've got an idea how to improve. Let's test it in a small way. Let's measure. Did it work? Oh yeah, it worked. Let's roll it out. Or it didn't work. Okay, let's forget about that. Let's test another one. That's basically DevOps. Optimizing for cycle time. And I said, that's not enough. Why? And here's a bit of history about that, because we have to understand a little bit where we're coming from to understand why this stuff is important, why it's crucial, and also all the technical stuff that we talked about the whole day is crucial today, and how that fits in. Let's start with a little bit of history of markets, economy and markets, how they evolved. What you often see in the literature, non-technical literature, is this kind of bathtub curve. I took that from the Beta Codex network, from their white papers, but you also find that in different places. And let's briefly discuss that. It starts here in a time where IT actually wasn't relevant, so end of 19th century, something like that. Age of manufacturing, so pre-industrial era. When you want to have something, a good something, you went to a craftsman and said, I want to have this and that, and described it a little bit, and usually you got it delivered exactly like you wanted to have it, and it was great, it was cool. Two problems with that. And for the craftsman, mastery was key for success. Two problems with this approach, even though it was really nice when you bought something. First of all, it was very expensive. Very few people were able to afford goods. It cost a lot of money, and not so. And the other thing, it didn't scale. So if you went to the craftsman and said, I want to have, say, one table, that's cool. You say, I want to have 500 tables. He said, whoa, stop it. And but we know how that was solved, industrial era, basically. Industrial era said, let's standardize these products a little bit, let's figure out an engineering way how to split that up in several parts, let's create this assembly line, and with all these stations, handovers, and so on, and then we can produce this standardized product, which Frederick Winslow Taylor and people, or Henry Ford, they perfected this way. And there's one important thing to know. If you're in a non-saturated market and you reduce the price by 50%, you can address about 10, 20, or 50 times the amount of customers. So you get a really wide market for you. Lots of opportunities to sell your goods. And this was exactly what happened back then. So what they got, they had a lot bigger demand than supply, which means the producers set the pace. The markets were slow, people were buying whatever you put on the market, which was great. So the basic challenge they had was to cost efficiently scale production. The more they were able to produce, the better it was. The more value they created for the market, and also the more revenue they created for themselves. And if they made it in a cost efficient way, also profit went up. So this was basically the core principle of production for all economies for many years. But eventually, things started to change over here. Post-industrial markets. And what happened is things like globalization, so advances in telecommunications and logistics, made more competitors available. We had the internet business, we had some other drivers. The effect of all that was that branch by branch, or domain by domain, once this relation between demand and supply started to turn around. After a while, the supply was a lot bigger than the demand, which made the markets small, highly dynamic. Who had the best idea drove the market. And the buyers, the customers became sort of picky. They just didn't buy anything from you anymore because you provided it. They said, no, I've got a lot of options, lots of choices. I buy this option which suits my needs best, which isn't necessarily only the cheapest one, but which suits my needs best. So if any of you buys at Amazon, who buys at Amazon once in a while? Yeah, so most of us, really. It's not that they're the cheapest all the time, but they suit our needs the best. And that's the difference. So if I want to have it cheaper, I go to a different platform, and quite often I get things cheaper. So it's about responding to customer demands. And if you want to be successful here, it's not producing as much as possible with as little money as possible, but it's a continuous communication with the market. what the customers want to have. Here's an option for you. Do you want to have it? Yeah, you want to have it. Okay, I'm doing more of that. Oh, you don't want to have it? Oh, wait, let's pivot. Let's do something else, and so on. Continuous communication, which is a completely different model on the markets. To wrap that up, industrial era, cost efficiency and scalability. We all know that, don't we? So companies who always focus on those two things. And post-industrial era, cycle times and adaptability and flexibility, which is a very different kind of model and a different kind of optimization you have to do for that. Okay, and the second thing is, now we're back to IT. How did IT evolve? Here's a little curve in here, time on the one axis, and the business support of IT on the other axis, starting from very selective to very holistic. It all starts somewhere in the late 50s. Back in the late 50s, IT became interesting for companies. Before that, it was mostly military and education, academic usage, but then it became interesting. Problem was back then, a computer, even a big mainframe, had about 1,000th of the computing power of your smartphones today, or even less. So you weren't able to do a lot with that. Here a little report, here a tiny analysis. But still it was cool. Remember, pocket calculator came up in the mid-70s. Back here it was all paper and pen calculations. And maybe a slide ruler, which wasn't also the nicest thing. So for multiplications it was okay, a slide ruler, but for adding up it just was in your head. So reports were great, and business departments wanted to have more of them. Problem back then was IT folks were still in a pre-industrial mode. So there were some guys, if you were able to get one hold of him and say, hey, I want to have this, could you program something like that, this kind of report? And if that guy did that, it was great. Unfortunately, these guys were very scarce and not available. So, and this was the start of the software crisis. A lot more demand than supply. And how to solve that? And the IT guys were quite smart, actually. Hey, let's think about that, let's sit down and revisit that. How can we solve that problem? Hey, didn't we have the same problem in industrial production just a few years ago? Let's try these concepts. And this was the birth of software engineering, basically. We are going to split up this task of software production into several stations, and we create a virtual assembly line. We call that software development process, this assembly line. And we have this specialists in there. Here's the requirements engineer and the business analyst and the architect and the designer and the coder and the tester and all these specialists down there, the network specialist and the database specialist and the storage, blah, 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 all these kinds of specialists down to ops. And that's what we had. And it was a great idea, basically, because now we were able to scale software production, scaling the possibility or the option to write more code with less money. And it was important back then. Software crisis didn't go away, basically, because the more code we were able to write, the more demand came up for that. They wanted to have more and more and more and more. After 20 years, people eventually said, oh, crisis would last for 20 years. Or maybe that's no longer a crisis, this is a normal state. So let's call the crisis ended, but the state never changed. Okay. And then it worked for quite a while, quite nice, these concepts. And then pocket computer, the personal computer, the PC came up, networking came up, and we were able to make more to support business in a more holistical way. And the problem is that in terms of system theory, business, people are involved, is always complex. You can't just do a decomposition of that, a divide and conquer technique on that. It's not that you can pre-plan everything and so on. And we ran into some weird problems when we applied these techniques over there, and you all know eventually agile techniques and so on came up to tackle these problems. Okay, but it went on, so Moore's Law did its job, and the internet came up, and we know what happened with that. And maybe let's keep that. Mobile devices came up, and had their success. And now I think basically that IT is the business nervous system of every non-trivial company. So nothing works without IT. Every single piece of your business is coded as DNA in your IT. In the worst cases, in a way that they say, oh, there's this system down there, we have no clue what it's doing anymore, but please do not touch it, it's crucial for our production. And never touch it again. All people who wrote that died meanwhile, and yeah, let's leave it as it is, but make sure that it will ever run forever. And sometimes they even don't have the source code anymore, which gives an interesting twist. So archaeologically. Yeah, business nervous system, which also means not only that it's crucial that your systems are always up and running, it also means you can't change anything on the business side without touching IT. So no new business features, no new products, no new processes, no anything without touching IT in some way. Okay, and two more observations. We stand here and we see quite often in many companies that our decisions are still based on that, which make things a little bit harder. And if you remember this curve, when we moved from here to there, so from the industrial model, industrial markets to the post-industrial markets, gives another twist because business today is very different from the business as it was back then when the foundations of software engineering were created and defined. So, different story. To wrap that part up, today I usually say IT has 4 roles, basically. The first one is the one I talked about, if we take the marks in the business. It's this nervous system, so the DNA of what's going on. The second role is the role of a differentiator. It's a quite new role. It's about 10, 15 years old. So we have some kind of disruptive technologies out there, like cloud, like mobile technologies, like the big data and fast data technologies. We have no clue what will be going on with IoT and some other things, which enable very new business models. So business departments in IT have to collaborate and exchange ideas to figure out new ideas, new business models. If you look at Uber wouldn't be possible without IT because it completely relies on IT. Also, Amazon without IT, forget about that. Bookstores would still be happy, and so on, and blah blah, and all that stuff. And so it's a differentiator, it's a second role, meanwhile. The third one is what I simply say, digitization, this hype word, Industry 4.0, digitization, everybody talks about it, nobody really knows what it is, digitization. And if you go outside of IT and read the magazines over there, it's interesting what you read there. Digitalization basically just means IT becomes part of the product, part of the business. You offer a product, a service as business on the business level. IT is part of it. That's basically digitalization. Digitalization is a little bit more, but that's enough for the moment. And the last one is communication medium. You don't go out to the pedestrian area and ask people anymore if you want to figure out if they like your services. You just say you look at the social media channels. You will figure out very easily if they love it or don't love it. I mean, you can still talk to them, but if you really want to figure out, especially for the new digital natives generation, what they really like about your products or don't dislike your product, you have to talk with them using IT, usually. Okay, that's a little bit different. So, what can we learn from this history? First of all, I think we live in an age of uncertainty. So we don't know anymore what's going to happen tomorrow. We don't know which demands our customers will have. We have to tackle uncertainty. You will find a lot of managers who will tell you, no, that's not true, but because it just attacks their core belief, their reason to be a lot. And that's probably the biggest problem in terms of transformation. Because as soon as many managers would admit that they have to deal with uncertainty, that they don't know what's going to happen, they think basically that their reason to exist has gone, which is a little bit sad because a good manager really can deal with uncertainty. But again, so how to deal with uncertainty? We need to go fast. We have to test a lot. So system theory tells you have uncertainty. Use, inspect and adapt, build, measure, learn, probe, sense, act, however you call that. Move fast, test all the time, learn all the time, pivot whenever you figure out that something doesn't work, and then you can deal and act with uncertainty. And on the IT side, IT is a core success factor to survive in this kind of markets. And the last one is that our traditional practices are unfortunately a little bit counterproductive because they are nice, but they solve a different problem, not the problems that we have today. Which in the end means, I think we have to rethink IT in some way. So not just take all that stuff which we learned for 20, 30, 40 years and just say, yeah, that's our foundations and we have to apply that all the time again and again and again and again. Because it doesn't work. Just doing more of the old stuff will not save us and will not help our companies. And that's what I see in most transformations and so on projects which struggle. They simply try to do the same stuff they did before, just give it a little bit of different painting, give it new shiny names, but still doing the old stuff and in a more perverted way instead of rethinking the basics. So I'm not sure if I've got the right idea how to rethink the basics. I offer you an option here. If you pick it or if you pick something other, have a smarter idea. You probably have smarter ideas than I have. But it's up to you. Here's the one that I have to offer. Very short way, very short version. So the drivers outside in view, the goals inside out view, and the building blocks. So a detailed view, but detailed, be careful, that's still 10,000 feet. And at least not 30,000 feet. New drivers. We've seen that one. We have to move, the markets are moving fast and they're full of uncertainty. We have to deal with that in IT because IT is the nervous system. So IT has to also respond to that. Digitalization, which gives us a new dimension, a new type of products. These products which are completely customer-facing, part of the solution, not supporting the business, but being the business. And we have to deal with that because it makes things even a little bit harder to create good solutions, which are really ready for that. And we also in IT, that's more technical driver, we have to deal with all these disruptive technologies and have to use them in a way that they create value on the business side. Okay. How to deal with these drivers. So we have to create, or you have to figure out new goals for ourselves. How do we want to run IT? What are our goals? Cost efficiency isn't the single most important goal anymore. That's for sure. But what are our goals? My claim is, or my take on that, first of all, being fast. Short response, short cycle times, through the whole IT value chain, how fast can you go from an idea until the customer sees the result and gives you feedback? And we're no longer talking about weeks or months, we're talking about days or hours. Actually, the best in class are in hours. So, and holistic value chain. So not figuring out a better way to collect requirements or a better way to run your tests or so on, but hey, does it pay on cycle times? So if I talk with teams about how to optimize everything, I just say, besides customer value, which is on a different page, for an IT team I say, it's 2 KPIs I care about. The first one is cycle time, and the second one is availability in production. So if you say test coverage is important for you, I don't care about your test coverage. If the test coverage pays on one of those, it's great. If it doesn't, kick it out. Find a different way, and so on. So if you say, I have to have stand-ups and everything like that, and I need to do Scrum, if it pays on cycle times, it's great. If it doesn't, kick it out. I don't care. Whatever, these are the 2 KPIs for me, and that's being quick. Availability comes later on. So flexibility, we have to adapt. Demands tomorrow are different than today. Effective, which is probably the most important thing to understand the differences between industrial and post-industrial drivers. The agile folks know that outcome and output. Output is how much you do. Outcome is how much value you create. And in industrial era, and that's probably the biggest difference. And if you understand that, you basically have got the key to talk to your CFO and to everybody else. Because in industrial age, it simply was the case, the more you produced, the more output you did, the more outcome, value you created. Linear relation between these two. Post-industrial, there is no relation between those two. You can create a whole lot of stuff, also in terms of IT. You can write with your team 1 million lines of code for this great idea this marketing manager had. And customers don't want to use it. They simply reject it. Really great output, 0 outcome. You might change one if condition in your code, which tweaks your application in a way that it reacts a lot more how your customers like it. And output, barely measurable. Outcome, great. No linear relation between those two things. And that's what you have to accept. So just measuring how much you did, velocity, everything, doesn't help you in these ages. You have to measure how much value you created. That's the unit of wealth today. Efficiency, yeah, we still need to be a little bit efficient, also a little bit cost efficient, not wasting money for nothing. It's still there. And robust, that's the availability thing I just talked about. And last but not least, entropy never sleeps. So as soon as we stand still, actually we go back, we become worse. So we have to improve continuously. Okay, nice goals. How to implement those? Just a very short peek at some building blocks. I'm not going into detail of all those because that would take too long by far. Here's just some domains. Typical ones, DevOps. Hey, great, we are here. Agile, lean, going away from these projects. They are way too slow, too much overhead in there for really becoming fast. And also making sure that you put in the right ideas. So if you produce crap very fast, it doesn't create a lot of value. And therefore, it's just a placeholder, the design thinking thing. So really caring about how to create requirements for this process. Organization level, DevOps, we will still see in a minute, will change your organization quite a lot with all these things like creating autonomous teams, cross-functional skills in there with end-to-end, and also routine task automation, all these continuous delivery, continuous deployment ideas. Change organizations still a lot because a lot of jobs which has been done before manually are now automated, and the people no longer think how to do the job but how to automate the job, which is a different story, which creates different job profiles, different requirements, different organizational forms, and so on. Hey, we talked about that quite a lot today, didn't we? I mean, yeah, that's the stuff we really like. We accept that the rest is there. But if I could, I would only talk about that. The problem is what I figured out is if I don't understand the rest, I'm not able to create any impact. So I just sit there, do the cool stuff, and say, why the heck is the rest around me still completely mad and nuts? And I sometimes try to at least influence it a little bit. I don't succeed all the time, just to be honest. But at least I try. Okay. Oh yeah, people, yeah. Oh darn, there are people, yeah. We always forget about that. I mean, whenever we talk about a big change initiative, we talk about changing the processes, so redesigning the processes, reorganizing, maybe a little bit of technology fancy in there, and we always forget about the people, but people are key in there. If you really want to go cross-functional, if you really want to become fast, you have to make sure that people can deal with that. And the first thing that you have to have, which is unfortunately on the lowest place, is empathy. Empathy is key today. I could give you a whole talk about that, but let's just have that in mind. So if you don't know what I mean with empathy is key, either ask me at the beer about that or look it up and probably you will understand. Because that's what really helps us. And empathy will lead us to T-shapedness, so also understanding what's going on around us without being complete experts, but at least understanding what's going on there and being able to communicate with those people. And the rest is also important, yeah. On the governance level, now we're on this very boring part, and therefore I just keep it short. There are ways how to deal with that. Okay, and continuous improvement, of course. All right, a lot of building blocks, and it looks really cool. So if we would all play a round of bullshit bingo today, somebody would already have said bingo, of course. Sure, but it's not by incident that all these things are on this table. So it's not that I just try to collect all the hype topics which are just around there and try to win the bingo. They're connected in some way to each other. And for the remainder of this talk, for the last 10 minutes, let's look at this for a moment. How are these all connected? And it starts with DevOps. So this DevOps, like I said, optimizing cycle times holistically. The role of DevOps. I mean, the first thing, yeah, quick repetition, yeah, optimizing cycle times, quick feedback loops, continuous improvement. And if you really take that serious and really try to optimize your cycle times, we will eventually rotate your organization by 90 degrees. So it will completely change your organization. What do I mean with 90 degrees? This is a traditional Tayloristic organization. Here's the process which connects all these islands by artifacts which are thrown across the fence from one station to the next one, the virtual assembly line in between, and all these specialist teams who make sure that they're never talking to each other except in terms of artifacts, which is the worst way. Okay, most of us are thinking agile today, which is already a great thing up to here. Unfortunately, the rest of it missing. And that's when the DevOps kicks in, basically. If you really want to optimize, you will figure out that you have to make sure that everybody talks to everybody. And because the whole IT department quite often is too big for just letting everybody talk to everybody, you have to figure out a different way to create teams, to shape teams. No longer just the specialist teams, but then you say, okay, let's organize by business capabilities and split it up in this way and put all the competencies in here in one team, all the skills in terms of skills, knowing and having the authority to decide how to do things, to go from an idea till the customer sees the result and can give you big feedback about that. So, I mean, that's the key, basically, in speeding up on an organizational point of view. You have to make sure that you put the decision authority and capability as close as possible to the problem. And lots of hierarchies make you slow. So all these skills and all these authority needs to be in the teams which face the problems and then can directly solve them, which gives you a different organization turned by 90 degrees. You can still also optimize that with some kind of platform teams, because compute storage network, if you don't take that immediately from the cloud, you still need to solve the same problems over and over again. And so let's build in a little bit of efficiency. Just make sure that this thing is pull-based, so these decide if they're going to use that or something different, and that they can pull it by API, because everything else gives you something like operations team 0.5. So still dictating how to operate things, but no longer taking the responsibility for that, which really sucks. So I've seen that in several companies start having this approach. And don't go for that, don't fall for that. But that's not everything, it's just the start, this organizational change. And let's look at that. So let's assume, yeah, we want to do this DevOps thing, we want to become faster. Here it is, DevOps. We start with DevOps Faster. And the first thing is, yeah, we just talked about that. Our IT department is too big for having everybody to talk with everybody, so we need to organize differently. And we end up with these cross-functional teams organized by business capabilities. Yeah, but that's not what we came for. Actually, we want to become faster. How can we become faster? And I also mentioned that briefly, we have to introduce autonomy. So this end-to-end responsibility for what they're doing, but also the authority to decide how to act on problems. Not having to run to your manager all the time, who has to run to his manager, with blah, 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 and then 2 months later a decision comes back, please solve it on your own. And which also brings you back to where you started. Okay, now they have this autonomy, but we still want to manage them. We want to make sure that they're really on the right track. How to do that? And then you end up with these ideas of decentralized control. So you don't no longer say, do this, do that, do that. You rather say, here's the goal we want to achieve. Here are some constraints. We can't move outside these boundaries. It's not possible. So as few as possible. And it's up to you how you get to this goal within these boundaries. I don't tell you how to organize yourself. So decentralized control, okay. But still, how can we figure out that they're really aiming for this goal? We still want to figure out that. So controlling not in the German meaning Kontrolle, so control, but more in this steering way, so getting feedback. Are they still on the right track? Have you really understood what I told them? Or have I still to discuss with the people and so on? Or helping them to get on the right track, so more in a supporting way, not in a dictating way. And yeah, as I said before, output doesn't help us anymore. I mean, all our controlling means in most companies are just based on output, on measurable numbers. So how much, even if you're agile, it's velocity, it's burn down, it's whatever, you name the metrics, it's all output. No single metric around there, and if you go into normal project status reports, there's nothing in which ever talks about, did we create customer value? No one. And in the end, that's the only thing which gives us the ability to survive, that customers use our services, that they're going, if we want to grow, they have to use our services more, and therefore we have to create more value for them. The good thing is, hey, we can measure that. We are in IT, that's great. We don't have to send out a squad into the pedestrian area, we can measure that. Is the feature used? How often is it clicked? How long did the customer go away from the page without going to the next page? If there's any volume, like money or anything else going across, how much volume went through this feature, and so on. We can measure, we can really measure, we can do the A/B testing, we can do everything to figure out, did we create value? We just have to do that. That's called business metrics. And it's not that hard, actually. We have all the libraries. We have the metrics library. We have the big data tools. We have the Prometheus. We have all that stuff we talked about this day. We can use the Crate.io, the Crate.db, whatever we need for that. It's all there. We have it all in our hands. We just have to use it to do that. Unfortunately, most managers don't understand it, so we have to help them to understand it. Okay, done. We just screwed up 50% of our whole governance model, so maybe we should rethink the rest of it either. And yeah, that leads to concepts like beyond budgeting, beta codecs, and so on. Different story. It's all solved. It's all there. You just have to read it up. You just have to apply it. Okay, you just have to is a different story. That is not that easy. Okay, management is perfectly unhappy now. Let's look a little bit at technology. How can we support all that on the technology level? So architectural level, because we have this autonomous teams, and if you have 10 autonomous teams working on one monolith, you will run out of meeting rooms very soon. So how to split that up, that also the technology helps them to move very autonomous. And yeah, you know that. It's microservices, self-contained systems, actors, you name it. But the idea of microservices is not, hey, it's cool that we can use now Spring Boot instead of a Tomcat container, which isn't really the difference. It's this idea, I help them to run in a mostly autonomous way. We don't get perfect autonomy, but as much as possible. Okay, but we still want to get faster. How can we help them to get faster? Which gives heterogeneity. No, it's no longer as necessary that you all run just on Java and the JVM or whatever the language of your choice is, or .NET or whatever. Do what best suits your needs. Because you as a team have the end-to-end responsibility anyway. So you will no longer screw with that. I mean, all the people are saying, wow, that leads to chaos, anarchy, these immature developers always want to toy around too. As soon as the feedback loop works with ops responsibilities, we will figure out how smart developers are all. They are not going to toy around with immature libraries if they have to wear something like here, like a pager, which rings them up at 3 a.m. whenever their system goes down. They may make very, very mature choices. They're smart, definitely. The only thing what was missing before was the feedback loop. Okay. And that's all nice, but if on the infrastructure level, if I want to have a new test server, and it just takes 3 or 6 months to get this instance running, not talking about scaling in production, how can we enable that? And here we are, yeah. Basically, it was the core of our today's day, a lot of Docker, Kubernetes, and so on. That's exactly that. Getting fast on the infrastructure level, getting this elasticity to help us to move fast and autonomously. And still, deploying one monolith once in a while is quite a pain in the neck. And now we have all these moving pieces on an infrastructure with this Docker, which is great, but sometimes not that great. Still a little bit tricky in some places and so on. And how do we avoid sudden death over here? Yeah. Continuous deployment, automate, of course. And in production, yeah, the one thing is resilience, because you have a lot of moving parts. You are now in distributed hell, which is very different from the monolithic hell. Both hells, but very different flavors of hells. And this is really a nasty one if you underestimate that one. Distributed systems are hard. And you have to build resilience in. You can no longer rely on the hardware, which is on cloud and containers anywhere. And so you have to build that in. A lot of stuff in there. And also in production automation. We talked about Prometheus this morning and so on. And all this automation thing that we need to have, and the monitoring and the self-healing capabilities, and. Okay, here's how all this cool technology stuff fits into the picture. But we have some other things. For instance, how can we make sure that these services all work smoothly together? That's what I call lean AAM. Maybe you remember this enterprise architecture management initiatives from some of the bigger companies, where some architects who were selected by making sure that none of them have coded for at least 5 years, were taken and said, you are now enterprise architects. And the first thing they did, they were buying a very expensive tool in order to create a lot of diagrams about their system landscapes and so on, which nobody cared about. And then in the end, the next 5 years they spent with complaining about why nobody cared about their nice pictures which they created with a very expensive tool. I've seen that, really. And I also talked to enterprise architects which exactly complained about that thing. And that's not what I'm talking about. I just say, if a dozen team needs to talk to each other. Their technology, their artifacts, their services need to talk to each other. It just makes sense that they just agree upon a few rules, that they don't have to negotiate everything from scratch when one service has just to talk to another service, which doesn't make a lot of sense. So we use message queues, we use HTTP REST-like. Okay, it's not really REST, but it's at least JSON on HTTP and so. And we use some kind of, we use SSL internally, or we don't use it. And a few standards that you need. That's everything. That's what I call lean AAM, filling the dots in between. And don't need to be some ivory tower team. It's also very perfectly fine if that's just some advocates from the different teams who sit down with each other whenever it's needed. And just say, okay, here's something we have to agree about. How do we do that? Okay, that's enough. Let's move on. And sustainability, let's have that quickly. Yeah, continuous improvement we talked about. But we need enough input. I mean, there's 3 releases a year that doesn't give a lot of points to measure from that. So we need quick feedback loops. How do we get that? Now where is this feature flow? Get rid of projects. Even if you want to become more radical, get rid of sprints and anything like that. Go more for a Kanban-like style. Just let your requirements flow through your IT value chain, because it's a difference if you get feedback, some feedback point, some data point every 3 months, or every 1 month, or every 2 weeks, or even every 2 hours. It's a big difference. So you need a lot of data for that, and so quick feedback loops. The faster, the better. And I forgot about the people. Yeah, it's the last thing. Promise, it's the last thing. So, what about the people? How do we can help them? First thing is craftsmanship. If you talk about craftsmanship, unfortunately, quite often, if people talk about software craftsmanship, they say, software craftsmanship, that's cool. I do a kata right now, and that's just the first value. The other 3 values say, don't only professionalize the way you do things, but professionalize the way you collaborate with others. So, and now we're back to this empathy thing, how to talk to each other, understanding a little bit outside your domain, and all that stuff. And from a company point of view, you can easily support that. It's called 20% time, sending your people to communities and hackathons and all that stuff, which does it. And sometimes also a soft skill training is quite nice. It's not the worst thing, even though if we always, when we have the choice, should we go to this cool conference here, which does a lot of tech stuff, or this awkward, soft skilly thing which my HR department somehow recommends. I mean, we always say, yeah, that's cool, techie stuff. Sometimes that stuff helps. Okay, let's make it 80-20, but at least it helps sometimes. So, T-shaped people, I talked about that before, and the empathy thing. Look it up, it's really worth that. I mean, empathy is probably the currency of us in the next years, which makes the difference if you're really a great developer or just a good developer. It's probably that thing. At least that's what I'm convinced about. Because I work with a lot of more or less autistic developers, which just were in their personal corridor, who weren't able to make a difference because they never understood what really was important, which isn't important. If you're empathic, you understand that. And it's no longer that you just run around and say, yeah, that stupid customer doesn't know how to write user stories. You will never say that again if you understand what means that. And the difference is, the customer is no longer stupid and you create results. He's so happy with you and, hey, it makes a lot more fun. Okay, and last thing is curiosity. Don't have to talk about that a lot because change is the only constant. So as soon as you lose your curiosity, it's a problem. From a company point of view, it's important to understand for not killing curiosity, you need a culture of learning and not of finding and hanging the guilty person. Because that's the thing which kills curiosity in 1 week. It's quite a lot of stuff, a lot of connections in here, a lot of things still missing in here, a lot of errors missing. But what can we learn from that? First of all the things are interconnected. There's nothing in isolation, even not your containers, even though they should be so isolated from your point of view. No, are part of a bigger picture in the end, of a really valuable picture. One topic on its own has a very limited effect. So one topic is nice to have, even continuous delivery, but it doesn't make a big difference from what we try to achieve. Because the effects, and that's also important to understand, this interrelations, they don't add up, they multiply up. One or two is a bit, doing a lot of them is a really big difference, a really big one. So this is how these companies, these unicorns came up. In the end, they did just a lot of those things and combined them in a sane way. DevOps, how I talked about that? Yeah, that's basically the driver of change, because it always says, how can we get faster? How are we going to get faster? How can we get faster without compromising availability? It always drives you. It drives you all the time. So that's a great starting point, basically. And that's more or less what I had to say. Yeah. Things changed, at least my perception, markets and IT, also the role of IT. I talked a little bit about the new drivers, goals and building blocks as I understand them. If you have a different option to offer, that's great. Talk with me about that. I'm always eager to learn. And DevOps results first of all in a reorg of IT, but it also drives us into a very new IT, which I personally find very challenging and interesting, because it's a great new time. We have so many new options, and we have really an option to change things and make a difference. So you're here, that's great, that's cool, because then you also have the chance to be part of that, making a difference. Thanks a lot.